Good afternoon. My name is Mike Miller, Vice President of Sales and Marketing for Edmonds, U.S. Joining us today will be Chuck Martin, Regional Sales Manager, and Alan Ramsey, Export and Technical Support Manager for Edmonds, Australia. In a few moments, I will begin the presentation with a new option for ventilation, advanced hybrid technology and its applications. Alan Ramsey will discuss market requirements and show a video demonstration of our EP600 and its functionality. Chuck Martin will then discuss Southern California Edison's approved testing and EcoPower performance. Alan will end the presentation with how Edmonds ventilators extract energy from the wind and worldwide projects. At the end of the presentation, we'll start the Q&A segment. Please hold all your questions till then. We also ask you to mute your phones until we start the Q&A segment. Let's get started. In this first slide, you will see on our presentation today that we're going to introduce a new option for old-style rooftop ventilation, Edmonds EcoPower Advanced Hybrid Ventilation. Now let's discuss the value of ventilation. What does ventilation do? It improves air quality, CO2 and odors. It improves human comfort, temperature. It reduces moisture. It also protects electronic equipment and reduces the load or eliminates it. How does ventilation work? Ventilation is an exchange of air, one parcel of air for another. When one parcel of air enters the room, one parcel leaves the room. A state of neutral pressure will be maintained. In order for an exchange of air to happen, two basic requirements are necessary. There must be a path through which the air can travel, and there must be a difference in air pressure to push the air along the path. If there is no air pressure difference, no air exchange happens. Air always travels from a high pressure zone to a low. How can ventilation be achieved? For a ventilation to happen, there must be a pressure difference to introduce air to flow. This pressure difference can actually happen naturally or artificially. Natural pressure happens by the movement of wind into a building, pressurization, or by hot air rising, the effect of warmer, lighter air. Artificial pressure requires a device to create a pressure pull, such as a powered fan to move the air. Using ventilation to achieve and improve thermal comfort. How can air exchange improve thermal conditions? Example, a factory generates heat. Simply replacing internal air with external air during operation will improve internal conditions. A warehouse internal temperatures can exceed external air temperatures. Again, air exchange from external air to improve internal conditions. In addition, for warehouses and factories with a well-designed purge option, it is proven to reduce daytime temperatures by up to 9 degrees. Design considerations for night purge. In the diagrams below, you'll see the advantage of night purge. The example today is for schools and warehouses. The use of natural ventilation mode during the day to provide minimal ventilation to meet air quality needs, and changing the power mode at night to remove hot air from the structures and introduce cool night air. Environmental support for ventilation over air conditioning. Air conditioning can normally deliver a guaranteed thermal outcome. Unfortunately, it causes additional greenhouse gases. In the example below, the Lifestyle Center replaced a 10 horsepower air conditioning system with 18 of our EcoPower 600 units. This 3-story office building was designed with a louver air system to provide for a night purge operation. The EP600s were powered only during the night purge. Power savings were estimated to be at least 6,000 kilowatt hours over a 5-month period. This translates into savings of 4.9 tons of greenhouse gases. As a result of the improvements, the building obtained a 5-star energy rating. Options for exhaust ventilation. The old choice, natural, which is the gravity and the wind turbines. Performance depends on environmental conditions. Mechanical, very noisy, high energy consumption, requires constant maintenance. New choice, hybrid technology that combines natural and energy-efficient mechanical modes. Edmonds hybrid ventilators combine natural and mechanical solutions simultaneously and give you the options for net zero natural mode and extremely efficient power mode. Now I'd like to introduce Alan Ramsey, Export Manager for Edmonds AU.
Thank you very, very much, Mike. I'm appreciative of the opportunity today to talk to you all about EcoPower. Thank you for the time you are making available. Referring to this slide, we started to develop the EcoPower concept back in 2004. Edmonds had been established in 1934 and had always focused on energy-efficient natural ventilation. We turned to our marketplace to establish what need was unfulfilled, and would like to remind everyone that this was largely before the world had various greenhouse gas emission targets in place and sustainability had become the buzzword. Already our markets were telling us that natural vents were valued but limited in their applications and abilities. They wanted a product that could act as a natural vent when conditions allowed, i.e. wind speed, stack pressure, environmental conditions were suitable, but could meet higher demands of peak when required. And wanted this with low energy usage, low noise, low maintenance, low weight, and the ability at work to best possible performance in the natural mode. They wanted the best of both worlds. The certainty provided by mechanical vents, yet the capacity to use natural forces when conditions were suitable. We took our highly successful natural wind ventilator, the Hurricane, the first vertical vane vent design, which was launched in 1989 by Edmonds, and after much research in conjunction with EBM PAPS Germany, who were world leaders at the time in electronic commutating motor technology, we fitted a suitable EC motor to the head of the vent. It became the bearing system for the entire ventilator, even in natural mode. No fan blades meant low noise and decent energy efficiency. 16-inch product was launched in late 2004, the 24-inch in 2005 and 36 in 2006. The product was called EcoPower. Patents were quickly established in Australia, India, Middle East, South Africa, and after much time we got through in the United States. This slide shows the innovative step undertaken, which became the basis of the patents. The photo on the right of the upturned EcoPower shows the motor located clearly at the top of the ventilator, and that being the innovative step. EcoPower was certainly a hybrid ventilator and a new class of ventilator. It could provide true hybrid operation through one product, not two or more, with no throat restrictions to impede natural flow, and that is critical. There had been attempts in the past to install a motor and fan blade in the throat of natural ventilators, but the throat blockage decimates natural performance. EcoPower offered an alternative to the old electric exhausters for the right applications. The EC motor, developed with the valuable assistance of the Germans, enabled a power reduction of up to 97% against axials using traditional shaded pole motor technology. Noise reduction was up to 14 decibels lower than equivalent standard axials. Moreover, the motor required no regular maintenance cycle and had a grease bearing life in non-stop mechanical operation of over 14 years. The slide I'm showing now was meant to provide a quick demonstration of the smoothness of the mechanical operation and the low noise output. However, from a few trials, it appears that it may not operate in this platform. I encourage you all please to have a look at the short 20-second video that was previously sent out. They say that every picture tells a story, and this short video will help all to appreciate this technology. If you can just have a look at that 20-second video, please. The revolution rate permissible from the motor had to be governed to ensure no possible overheating in this novel application. That function is performed by EBM before Edmonds receives the motors. Because of this initial concern, Edmonds did not permit variable speed control of EcoPower until 2016. The product operated in either natural mode or full permitted speed mechanical. Various technology breakthroughs with motor design enabled Edmonds to move recently to offer two means of variable speed control for all EcoPower sizes. Firstly, we have a so-called smart box, which we call AirIQ. It's installed on each unit and acts as a personal BMS for each unit. It can control on the basis of temperature, humidity, or both, and varies motor speed, which in turn impacts head rotation rate and therefore the flow rate of the air. Secondly, we can have a so-called interface box, which simply takes a Cat6 cable, providing 0 to 10 volt control from a centralized BMS. Often the BMS will have internal and external temperature feeds. An algorithm programmed into the BMS will determine how the vent operates. This slide shows the smart box controller, which is capable of Bluetooth control from an app supplied by Edmonds. The app will enable reprogramming of control settings. The standard setting, just enabling on-off control, remains an option there. The smart box comes with default settings unless the customer has requested preset conditions. Temperature or humidity may be controlling the speed of the ventilator depending upon which variable exceeds its preset minimum first. Humidity default is 65%, while temperature minimum default is 77F when speed rises to 20% of permitted capacity. It then ramps up to full speed at 104 Fahrenheit. But I stress these settings can be reprogrammed to suit various geographic conditions. This slide shows total BMS control of a full scheme of EcoPower units using variable speed control through a 0 to 10 volt signal. This type of operation has already been carried out in the USA at Washington University. It can facilitate a very effective night purge operation. Here we see some of the projects that have used EcoPower for temperature control. Automated warehouses these days, such as those used by Amazon, have large robotic operations. The electronics of the robots can be very sensitive to high temperatures, and EcoPowers have been used as part of a total cooling system, even with evap air unit, an application of night purge. Same applies to sensitive communications-based equipment, such as that used in wireless transmission stations and national broadband rollouts. Gymnasiums are another excellent application, as players exude considerable heat and sweat during basketball games. And of course, manufacturing is a huge market area. There are many processes producing heat, such as furnaces, injection molding, ovens, digestion, baking, welding, and heat removal is necessary to provide decent working conditions. While the need for humidity control is not as common as temperature, it can occur with shower blocks, toilet rooms, squash courts, and buildings where valuable paperworks are stored, such as libraries, archives, or even state records. Acknowledgement of the technological breakthrough with EcoPower came quickly in Australia when ERA, which is an affiliation with ASHRAE in the US, awarded the technology the Excellence Award for HVAC in 2008. Edmonds did not rush EcoPower technology around the globe, but preferred to first ensure no performance issues showed up locally. A few US projects were supplied in 2009-10, and then sales made to Germany to replace 3 kilowatt air conditioning usage in over 300 E+ wireless transmission station projects through 2010 to 12. But it was not until 2016 that EcoPower was taken to the huge Middle East cooling market. Our Hurricane Natural Ventilator had been a very early success in that market since 2001. In 2016, Edmonds, the EcoPower won the highly rated Gaia Award in Dubai for product sustainability. This was followed up in 2017 for success in the UAE MENA Awards for Best New Product in category Energy Efficiency and Sustainability. In terms of certifications, this is a subject that Edmonds, as an ISO 9001 manufacturer, takes very seriously. The performance of all 3 EcoPower sizes has been evaluated by AMCA and the product catalogue certified by AMCA. Products were also submitted to UL and approved back in 2009. I would now like to pass over to Chuck Martin, Regional Manager for Edmonds US, who will continue this presentation.
Thank you, Alan. Southern California Edison has recently approved the EcoPower exhaust fans for their emerging technology program. The purpose of this program is to, number one, evaluate all new energy saving technologies, verify product performance through independent testing, promote the use of these products in current projects, and document the long-term energy savings. They've already identified projects at the University of California, Irvine, and Santa Barbara. In addition, they are recommending the EcoPower products for a factory that produces car wheels in Oxnard, California. Once the energy savings have been established, Southern California Edison will offer rebates to encourage the use of these projects. On the performance side of things, the key to this hybrid technology is its low power in operating mode, while extracting energy from the wind and providing free ventilation in the natural mode. In the operating mode, power consumption ranges from 1/10 of a horsepower to 3/10 of a horsepower. With 20-mile-an-hour winds, you will reduce the power consumption by approximately 6%. At 33 miles an hour, you will save up to 17%. Under average environmental conditions, under the natural mode, you'll get about 20% of the airflow generated by the power mode. With a 33-mile-an-hour wind, you get 100%. Now let's visit 5 projects and examine the energy savings. The photo you see is a power station in India that replaced a 5-horsepower exhauster with the EP600 at 0.14 horsepower. Reliance Energy generated a report that completely details the installation and confirms that the EP600 saved 97% of the operating costs. They also noted the ease of installation and elimination of maintenance issues. Note that this report is available upon request. The university dorm application in Southern California was brought to us by Atlas Mechanical. They are the MEs for the dorm project. They asked us to perform a comparison between our EP 600 and 900s to the GreenHex 180s and 161s. These were the devices that they used in the current design. The analysis showed a reduction in weight of 58%, a reduction of operating power by 42%, sound reduction of 11 dB, 20% increase in the amount of CFM available, energy savings of $113,265 over a 5-year period at 10 cents per kilowatt hour. These savings generated a 3-year ROI. At the University of Washington, they used 8 EP900s to ventilate the biomolecular lab. The design was so unique that Green Building and Design magazine published an article entitled, "Who Says You Need Air Conditioning?" The EP900s eliminated the air conditioning in 40% of the lab. It also, the university obtained gold LEED rating instead of silver due to the use of the EP900s. They also used them in their nanotechnology lab design. Visitors from the other university buildings commented that the AC in the lab was so much better than their building. The building manager informed them that they were only using ventilation. You can view the actual interview with the building manager on our website. In Hawaii, the 600s were used to replace the existing 3/4 of a horsepower axial fan. The project manager projected 80% energy savings, but actually measured 90. The extra 10% was attributed to the extraction of energy from the trade winds. In Maui, we have a project going for the Harbor Lights condominium. They were experiencing failures in their green heck exhaust fans. Energy Consulting Associates proposed the use of the EP600s to replace the axial fans on this 4-story complex. Their analysis showed a reduction in maintenance cost and energy savings of over $107,000 a year. As you can see from this slide, the use of the EcoPower fans offered a simple solution to reducing energy consumption. Now, when we look at major opportunities, they fall into 2 categories. The retrofit projects, they are the obvious choice for swapping out old and failing axial exhaust fans. You will obtain energy savings from these fractional horsepower replacements, a reduction in noise, an elimination of maintenance, and the ability to meet new energy requirements. With new builds, you'll receive these same benefits that could be applied to LEED requirements, zero net energy mandates, and end user demand for lower energy solutions. The primary applications are shown here on this slide. We have provided 5 examples of significant savings obtained by using EcoPower products in these applications. There are more applications that can benefit from using this unique hybrid technology. Every design needs to focus on energy savings and the sustainability obtainable by using the very best solution. Now, Alan will provide test data on the extraction of energy of wind and discuss other worldwide projects.
Thank you very much, Chuck. One of our most interesting discoveries about EcoPower, which Chuck has already alluded to, occurred from the project on the Tau product in Honolulu. We replaced energy-thirsty axials under the HECO rebate scheme. When it came to a final analysis, HECO advised that the energy savings were much larger than forecast. Back to the lab we went and discovered that the strong afternoon trade winds in Honolulu had effectively helped to reduce the power draw. We established that after wind speed exceeded 20 miles per hour, the energy usage declined, as shown here. In effect, our product had another element of sustainability, the ability to harness energy from the wind while in power operation. Here we see a splattering of major projects undertaken with EcoPower around the globe, from universities and schools in France to industrial projects in India, replacing air conditioning usage and wireless transmission stations in Germany, at Washington University, Seattle, and national broadband control centers in Australia, projects which were project managed by Emerson, I should say, warehouses and factories in Europe and the Middle East. A very diverse range of applications in a great variety of geographic regions. I'm highly conscious that you folk are out there advising warehouse owners and manufacturers, as well as commercial building proprietors, how to reduce their energy usage. So I'm now turning to a few examples of the many warehouses and factory projects where we installed EcoPower. Here we see the use of 22 EcoPower 900s on the major Caterpillar warehouse for Southeast Asia, located in Singapore. Next, we see a very recent project here in the States at LA County Office of Education warehouse, where 3 EcoPower 900s were installed. It has been assessed that they have substantially improved working conditions for warehouse staff. Now we turn to a project for a major fibre cement sheeting manufacturing plant in Sydney. It's owned by our father company, a company well over 100 years old, I might add. Fibre cement manufacture is a wet process and exudes much steam and heat. A massive 72 EP900 ventilators were installed with a cost exceeding $250,000. The estimated payback compared to using alternative technologies was under 3 years, which is essential to gain capital approval for our father company. In conclusion, eco-power ventilators provide fast returns for end users, particularly if natural mode can be used for proportions of the day and or the year. They require no maintenance for over 14 years, are extremely quiet, are manually light and easy to install, and finally are fully controllable through a BMS or own smart box technology. And just this week in our own state of New South Wales, they are now capable of securing what are termed energy saver certificates worth an estimated $715 US in the Sydney climate zone when used for ventilating small businesses.
We at Edmonds would like to thank you for giving us the opportunity to present the Edmonds hybrid EcoPower technology to you.